Alright, for my final sprint submission, I will be running through the checklist of the expected engine's features first. Next, I'll be following up by showing off the demo and the demo code, and then I will follow up by showing off the documentation for the engine. Um, First things first, I'm starting off with the main engine class. This is the main engine class. What was required, reading over here, showing this is going through for all the various sets and gets. For the class, it is derived from the engine class. It is a singleton, and it follows the attorney-client idiom, so it has an attorney through named Lotus Engine Attorney. Going down here, this is the set window, set height, width, height, all the getters, and deleting, cleaning up for the instance pointer. This is the Lotus Engine Attorney. It's front class with freeze time, so it gets the time from that. Next, going over, this is the game initialize, loading the content, so it calls this load resources, so that load resources is separated over here into the C++ file, so it's just going in, loading a default manager and loading all the various models that the user has implemented and wishes to load in, and then various for the textures, the sprite fonts, the image manager, and then this user-defined game manager, which initializes the start scene. Next, just keep going further down into the main engine. So this is just, like I said, this is where the unload happens. It's unloading all that stuff that was loaded in from the model manager, the texture manager, the shader manager, the image manager, and so on, and then making sure you're cleaning up for the scene manager, so for the time manager, and it's cleaning up for sprite, and making sure that the visualizer is cleaned up as well, and cleaning up for this screen log tool. Next is to go through all the various asset managers. So starting off with the asset manager, the image manager right here. Starting off showing the .h. This is it is a singleton. Cleanup for its instance pointer. It's the getters, the load for passing in a string and a texture, or passing in a string, texture, and then a rectangle pointer. So this is default path going through into the path for the textures, where all the textures are being held. And then going through cleaning up the map getter, making sure that you're going through trying to find the key. If it's not found, it throws an error. Loading, making sure loading a new model from the file, and then you're preventing key duplication, and if the key has not been used, then you add it and insert it. Same with this one, again preventing key duplication. If it has not been added, then add it. Otherwise it throws an error. All the other managers are set up very similarly, so I will briefly go through, show the .h's and the C++ files for those. This model manager has this load default model, so that was set up for the sprite to use. Again, has this get, this load, and this load default. This is set up for the sprite. And then this load is when it's using a pre-made model. Shader manager, another singleton, more private gets and load. And this one is set up with these constant strings for these various shaders that the user would use that would be defaulted. So then, and another difference here is that it has this load default shader. So inside of that load default shader, it's just loading all these various shaders. So it's loading the constant, the color constant, the color no texture, texture flat, texture light, and the sprite render and sprite line. Sprite font has another singleton. This one just has the simple get and load. Private get, private load. texture manager. This one is using a few overloaded, so this is for the key, the path, and this is just for setting up the default. It's an optional variable. The load and the gets, again preventing key duplication and making sure you're throwing an error if the key has already been used. Continuing on with what's following in the checklist is the time manager. So the time manager is also using an attorney. Here's the .h for this. It is a singleton. It has these various process time, terminate, get time, and get frame time. Process the time is a static void and has these public functions, so it can get the time and get the frame time. Over here it is using this freeze time, so that if the user chooses to freeze the time, they can press F10 and then press F9 to continue on at a frame-by-frame basis. So this is the freeze time. The freeze time was a class that was provided to us so that we could use this tool as a means to test various things as with time. Next is the scene management. So let me go over into the scene manager. Let me close up these asset managers. Next we'll go to the scene management. And then here is the scene manager. Scene manager setup with this, it is a singleton. It has these various private functions. So it has this change, update, draw, terminate, and the initialize the start scene. It has a pointer to the camera manager, and has pointers to all the various commands. So it has the change command, the scene change, and the null change. And then these are functions that the user is able to use. So you can get the current scene, you can set the current scene, and then you can get the camera manager. Here's the C++ file. So inside of the draw, you're calling through the scene attorney, and you're using the game loop, and you're drawing, and then you're passing in the current scene. Getting the current scene is just returning the current scene. Initialize is going through the scene attorney, going through its game loop and initializing the scene, so it passes in the current scene. The scene end, this is again going through the scene attorney and then passing into the scene end, and then it's ending the current scene. Update is just executing the scene change command and then updating the current scene. Setting the next scene, so it's just using the change command. So it's if the change command is null, it's going through creating a new scene change command, passing in the scene. Otherwise, it sets the scene, and then the scene manager is setting the next scene. Changing the scene, calls the scene to end, deletes the current scene, and then sets the scene to the new scene that's being changed, that's being passed in to change that particular scene. And then this is just cleanup for the scene manager. Next, we're going to go through into the scene class. So scene class right over here. This is the .h. Various pointers for all the managers required for the scene. So you have the alarmable, the updatable, drawable, camera, keyboard event, the registration broker, and the collision. So these are internal only. These draw and update. Registrations for all the various ones. So the update, draw, alarm, input, submitting the command. Has the camera manager, and these are functions that are protected. So these are functions that that derived classes use. So it has this initialize and the scene end, and then those classes can use to set up collision pairs and then set collision self. Here is the constructor for the scene, submitting the command. So it goes to the registration broker and then adds that command. Registration broker then executes those commands, and then various processing. So it processes through the keyboard event, processes through the elements of the update, and then processing the collisions, and processes the alarms through the alarm manager, all the corresponding managers. Has this draw, so it's processing the elements for the draw, and then all the various deregistration and registration for all managers. So it has for the update, the draw, the alarm, and the keyboard manager. So over here is the camera manager, just gets the camera, and then at the destructor, it just deletes all those pointers. So there is cleanup for that. Next is going through the update and the draw. We'll start off in the update. This is the update manager attorney. It is a front class with the scene. So it's going using the updatable manager, passing it through as a parameter, and then processing the elements. Inside of the updatable manager itself, it is here's all the required methods or functions, excuse me, and setup. So this is the big four, and then the register and then deregister. The register is passing in an updatable, and then having the storage reference. Inside of the C++ files, the register, the deregister, processing the elements, going through iterating at the beginning of the list, and then iterating through to the end, and then making sure you're updating that particular updatable. The updatable is using the attorney client idiom as well. This is the setup for its attorney. Has the class subclass game loop, subclass registration, and subclass deregistration. This is the updatable.h. Using this enum class for currently registered or currently deregistered, pending registration, currently registered, and pending deregistration. And then this updatable manager storage list reference is used for faster deletion. Has pointers to the two commands, so the update registration and the update deregistration commands. And then going through the registration state. So these are the user commands, so it can update that particular updatable to submit its registration and submit its deregistration. Here is the C++ file, asserting, making sure that all the corresponding registration states are passing through correctly. Submitting over here for the update command, making sure it's going through the scene attorney to submit that command, so it gets the scene and then it passes in that registration for this updatable. And same thing for the deregistration. And then the updatable destructor makes sure that it deletes those commands. Here is the update registration command. It is derived from the command base class. It has a pointer to an updatable. And then it has right over here for the update registration command, and then a virtual execute. So inside of here, it is just setting up the pointer to the pointer that is being passed in, and then making sure that you're going through the updatable attorney registration and going through the scene registration, and you're registering this particular updatable. Very similarly, and you're making sure you're deregistering this particular updatable. Next is the draw. So this is the drawable's attorney. It has similar to the updatable. It has a subclass of game loop, subclass of class registration, and a subclass of deregistration. Inside of drawable.h, so very similar to update. It has all its registration state, its draw registration and deregistration commands. Has the virtual void draw and the virtual void draw 2D for the sprites, and then these are the command functions. So for these, the user would then again have to call these and make sure that it's submitting to draw for that particular game object, which derives from the drawable. This is the .h, very similar to updatable, making sure that all the states are correct for that particular function, and cleanup for those registration and deregistration commands. Here's the .h for the draw registration command. The draw registration command takes in this drawable pointer and has this execute, which is derived from the base class of command base. What over here is just setting whatever is being passed into its drawable pointer, and then passing through the drawable attorney, going through the registration, scene registration, and passing in that pointer. Deregistration set up in the same manner, going through, setting the draw to the pointer being passed in, and then passing into the scene deregistration through the drawable attorney. The next thing was to show the drawable manager attorney. So this one again is using an attorney. It's friends class with the scenes, processing those elements. .h. So again, having these register and deregister public functions. Inserting the drawable to the storage list. And then deregistration, processing the elements for both 3D and 2D. And that is the setup for the drawable and the drawable manager. Next, going through the alarmable. So this is the alarmable manager attorney. This is what the scene uses to process the alarms. So over here in the .h, this is the .h set up in the same manner as the other ones. So this one has an enum alarm ID, so it has 3 alarms, alarm 0, 1, and 2, so that gives you a total of 3 alarms. It has this alarm using alarm event. It is a pair using the alarm pointer and the alarm ID. This is a timeline map, so it's a multi-map, taking in a float and the alarm event, so it takes in the alarm and the alarm ID. Have these absolute times and free time. The big 4, and then this is for the iterator, the registration and deregistration. Registration, so this is registering, getting the time from the time manager, inserting it, making sure you're passing in for that pair, so you're passing in the time, and then the pair is the alarmable ID, alarm and the alarm ID, processing the alarms, getting the time going through, and then making sure that timeline is not at the end, and the first is less than or equal to the absolute time. Going through, triggering the alarms for the second first, and then the second. Next is going through the alarm attorney. This is the alarm attorney set up similar to the other exables. It has a class game loop subclass, a registration and deregistration subclass. This one in particular, because it has to take the ID for that particular alarmable, for that particular alarm, so that's why it's passing in this alarm ID. Here's the .h for that. Has an enum class registration, and then a struct for the alarmable timeline, so it's for the deleting reference, the alarm current state, the alarm registration and deregistration pointers, and it has this registration data array, registration data for the number of alarms. The alarm, so it's the alarm 0, alarm 1, and alarm 2. Triggering the alarm, alarm deregistration, and alarm registration, and then making sure that you're submitting the alarm registration, passing in the alarm ID and how long the alarm is supposed to go off for, and then make alarm deregistration, passing in the alarm ID to deregister that particular alarm. So this is triggering the alarm, so it goes through, deregister it first, and then going through the switch, and then triggering that alarm. Alarm registration, alarm deregistration, submitting the alarm registration, and submitting the alarm deregistration. And then this is cleanup for that, so it's going through and making sure you're getting rid of the pointers for all the alarms. Next, this is the alarm registration and deregistration command. So it has a pointer to the alarm, and it has this alarm ID variable as well, and the time. Has the big 4, this alarm registration constructor, and execute, and it has this set time as well. So right over here is just making sure all the various things that are being passed in is being set, and then executing it, going through the alarmable attorney and registering the alarm, passing in this pointer's this alarm registration's alarm, the time, and the ID. The registration set up very similarly, just without the time. Going through, getting the alarm and the alarm ID, and execution. Next is going through the keyboard event manager. So this is a keyboard event manager set up with an attorney as well, processing the key events, which is called from the scene. Keyboard event manager, so it is friends class with the keyboard event, so it has this keyboard, the map. So it has the Azul key and the single key event manager, and then has this map key event manager, map single key event manager. Has this process key events, big 4, and then the registration and deregistration. Here's the C++ file. Again, processing the events, so it's iterating, processing key events for single key events. So that then it calls and processes the keys for those single key events, and then registering. It's going through. If the single key event has not been created yet, make a new one, register it, and insert it to the map. If a single key event is already created, then just simply register it. And then this is deregistration. Going through single key event setup. So it has an inputable collection, which is a list of inputables. It has an inputable collection for the key press and the key release, and this bool to check if it was pressed. Process key events, register, and deregister. So inside over here, this process key event, so it has for the iterator for the press and for the release. So it's going through, getting the key, making sure if it was pressed or if it wasn't, and if it was not pressed, then it goes through. Well, the iterator press it is not. The end of the list goes through, sets an inputable to it, and then passes it through into the key pressed. And then it sets the press to true. And this is to check if it was pressed, then it goes through and goes through key released. This is the registration. If the key event, get the input event type. So if it was key press, it inserts it to the key pressed. Otherwise, it inserts it into the key release. And then the same thing for the deregister. Next, we go through into the inputable itself. So this is the inputable attorney. It has separated, very similar to the other exables. Game loop, registration and deregistration. Has a key pressed, key released inside of the game loop. And then registration and deregistration. Here is the .h for this. So this is for the inputable. Has the registration state, the registration data for this. And it has a key event, which is a pair of input events, which is the key type. And then inputable key, so it's the key event and then the registration data. And then it has this inputable keys map and the inputable keys iterator. So there's this, these are the virtual key pressed and key released, and the input registration and deregistration, and the submit key registration. So these are the functions that the user uses to register a particular key, and which one it is. So if it was for a key release or a key pressed. Inside here of the C++, this is the input registration. So it goes through and it finds that particular key and then the key event type, making sure that it's pending registration, going through the scene attorney, registering it, passing in this particular inputable, the key, the event, the reference, and the single key event. going through input deregistration, very similar to registration, and then the submitting the key registration. And right over here in the destructor, making sure going through and deleting all those particular commands for the keys. Next, we go on over to the collision manager. So this is the collision manager attorney. It is used through the scene, and this is what it's uses to process the collisions. Inside of the collision manager itself, here's the .h. So it has this group. So it has this type. So this is what's used to identify for the collision type. And then next it has this using collidable group collection. So it's a vector for collidable group collection. And using the collision test command. So it is a list of collision test command base. Has a set group for the ID, processing the collisions. The big four going through has this template so you can get the ID, and then sets the group for ID, and then have this debug right here where it prints out what the type ID is. The set collision pair, and it's using the dispatch, and then going through for the test commands, and then pushing it back and adding it in for a new collision test pair for this particular one. And then right over here, this is for the self. And right over here, this is for the collidable group to get the particular collidable group. The .h, making sure type ID next is set, and then setting the size of the collection group, or the collision group. Setting the group ID. If it's null, then you set it as a new collidable group. Then this is just getting the collision group for that ID. Collision destructor or collision manager destructor, going through the collision group, deleting it, and then making sure that you're deleting the collision test command from the back, and then popping it. And just processing the collision. So going through the collision test command iterator, you're at the start of it. If it's not at the end of it, go through and execute those collisions. Next, I'm going to go through the collision dispatch base. So this is the base for that. Has this process callbacks, taking in 2 collidables. And here's the collision dispatch. It has this right here, this process collision callbacks. Goes through and calls the collisions for those particular collisions. So it's collider 1 and collider 2. Here for the collidable group has the register, deregister, and get collider collection. Here's the .h, passing in the collidable and the collidable collector and reference. So setting the reference to what's being inserted. So it's the end, and then passing in that collidable, going through erasing it, and then returning the collidable list. Next is this is what's used to test for the collision. So it's using a B-sphere. It's computing the data, checking the intersection between the 2 B-spheres, and for this particular one, it's just a collision volume. And then right over here is the intersection for the B-sphere. Has the get radius, get center, and get command. It's the C++ file, so it has compute data, getting the center, getting the radius, and setting the matrix. Right now, the intersection between a collision volume is returning false. There's not much going on in there. The intersection between another B-sphere is where the math is happening. So it's getting the center for this particular B-sphere and for the other one, and then getting the magnitude of it, checking it if it is less than the radius of both, and if it is true, if it is less than that, it returns true. Have these getters, and going through making sure you are cleaning up for the visualizer. So here's going through for the visualizer uses an attorney, so set up in 3, so it has a game loop, visualize all, and a command process. So inside of the .h, it's friends class with the visualizer. It is set up as a singleton, has this command of visualizer commands, or it has this list of visualizer commands, and has this public show bsphere. Here's the .h. Showing the sphere, rendering it, and visualize for all of the b-spheres. I'm going to start off by showing off the visualizer command first, and then I'm going to move on to the actual collidable class. So this is the visualizer command, visualizer.c++, using the visualizer command process and rendering the b-sphere. And that's all that's really going on inside of the visualizer command. Here is the collidable attorney. It has a game loop. It's friend class with the collision manager. Has a class registration and deregistration. Inside of the collidable, has this very similar enum class as all the other exables. Has this collision manager ID type, so right now it's set up to an undefined. This is used for fast deletion in the manager. Has the current state, registration and deregistration, and right has a collision data, so the collider or the model and the b-sphere. So it has these templates. So set the collidable group, submit the collision registration, submit the collision deregistration, set the collider model, and update the collision data. Has this virtual void collision, and this is for getting the sphere. The constructor, scene registration, scene deregistration, submitting the collision registration, and submitting the collision deregistration. Right down here is for that, setting the collidable model, so it's whatever's being passed in, setting it to to whatever the model is being passed in. Updating the collision data, so it's grabbing the b-sphere and computing that data. And then this is just a getter for getting the b-sphere. And then the destructors making sure you're cleaning up the registration and deregistration commands. Next, going through the game object lifecycle. So this is the game object connect and disconnect through the game object attorney. Game object.h, game object.c++ file. So right over here for this, it's when the game object itself calls for the submit entry and submit exit. So it is using those commands. And next I'll be showing those commands for those game objects. So here's the game object exit, game object C++ file, game object entry, and the game object entry command C++ file. To show that there is a life cycle going on, I will be demoing that through the bullet. I feel that the bullet is much easier to show that when something is being called for the entry and the exit. The bullet is probably the best example for that. Next is for the sprite. So this is the sprite itself. This is the .h for the sprite. C++ file. Getting the model for this is getting the sprite render, the image, getting the image key, and getting the image for the image rectangle, rendering it, setting the angle, setting the center, setting the position, setting the scale factor, and setting the scale pixel, getting the angle, getting the height, getting the width, and then making sure you're deleting that graphics object. Here's a sprite font. So sprite font C++ file, loading in the associated texture, making sure we're cleaning up when the destructor is called, the XML collection, making sure that we are loading in the correct image, the associated image to it, and then adding it to the the key into the font map. And then down here for this get, going through iterating, making sure we're finding the glyph. Next is the sprite string. So it has a glyph collection, which is a vector of lotus sprite. You can big 4. Next has this sprite string, get height, get width, render, setting, C++ file. So to demo this, I'm using this through the screen log. I'll be showing off how that is using this sprite string when I go through the demo of everything. So here's the screen log. So it is set up as a singleton. It's using the class sprite font. Here is the C++ file. Getting the font for that particular, for the sprite, for the screen log. Adding it. Getting the glyph, setting its position, and then rendering it. So that's what that render is for. I'll show that the screen log render is being called inside of the engine. So right over here, the engine is calling that screen log right there. I already showed the visualizer as I was going through the collision, so let me go through the math tools. So right now I believe the only thing I have inside of my math tools is this intersect. So intersect is similar to how I was using inside of the volume B-sphere. So it has that same mathematical equation where it's getting checking the after subtracting the two centers of the B-spheres, it's checking the magnitude to see if it is less than the radius of both spheres. Next, I will be going through that color namespace. So this is something that was inside of graphics. So I grabbed all the vectors to have all these colors in place so that you can use these. Next, I'll be going over the demos. So I'll be showing off how the life cycle goes through with the bullet. And next I'll be going through and showing that the user is registering for all the various exables. So it's registering for the update for the draw, registering the various alarms, and making sure that you're updating for the various key inputs as well. So here are all the user callbacks for that. So it's calling for the update, the draw, the key pressed, and key released, alarm 0 and alarm 1 for the scene entry for the game object lifecycle and the scene exit. So first, when it enters the scene, it is submitting for the collision registration, making sure you're submitting for the update registration, drawable, and for the alarm, making sure that you are submitting the alarm. Inside of the scene exit, you're submitting the collision deregistration, draw deregistration, submitting the update deregistration, and then submitting the deregistration for the inputables as well. And then recycling this particular enemy in case the player the user wishes to implement multiple lives. So for the bullet itself, this particular bullet class is used by the player. It is not used by the enemy. So I will hold off so that I can show that once the bullet enters the scene entry is using, and then it submits this alarm registration, submits the update registration, and all the various registrations. So I'll run and demo this. And then I'll place another one down here when it's time for when the bullet deregisters and exits the scene. So there it is. It just registered the alarm, registering the update and the draw, collision, and then the scene entry was called. So then we'll go ahead and continue. And then now the bullet scene exit was called after the bullet, the alarm had gone off. So after the alarm had gone off, that's when it submits it for deregistration. So it just submits the exit, and then it's going through and deregistering everything. It also calls this scene exit when the bullet has collided with an enemy. So that was likely the case, that it indeed had collided with an enemy. Next, I'm going to go ahead and fully demo that the player as that the game is playable. So the player is able to attack other enemies. So here's the enemies being attacked. Once the player defeats all the enemies, they are able to move on to the next. Right now, I'm going to likely lower it, the amount of enemies, so I can just demo that a lot quicker. So I'll go through the various demo code that I have implemented here. So I have this ammo crate where the player, once they run out of once they run out of ammo, they cannot fire anymore. So the player has to pick up ammo crates in order to continue firing. And then I have these managers. So the game managers, how it handles swapping from level 1 to level 2. To give, if once the player has completed, has defeated the amount of enemies, then they will switch over to level 2. So let me go ahead and lower the total number of tanks. So let's go with 3 enemies. So it'll go over from level 1 to level 2. And then on the second level, I have this implementation of a second enemy, which is a jet. So this is the user side of everything. So this is my second enemy, the jet. Calling this collidable, setting the collidable group. Right over here in the initialize, you're setting the collidable model, updating the collision data, and then making sure that you are updating that collision data inside of its update. This rudimentary, AI, and then has this draw, the alarm. Inside of the alarm is firing the bullet. So that has this separate enemy bullet. And when it collides with a bullet, it lowers its health, and then once its health reaches to 0, it submits this enemy for exit. Again, set up similarly, so it has the scene entry, scene exit, and then making sure cleaning up for its graphics object. Next thing, it's implemented player tank. This the player tank itself has various callback to various collisions. So for the car, game, the tree, enemy bullet, health pack, and the crate, ammo crate. So again, set up the same for the inputs for the registrations, and then this is the key pressed, key released, the draw, the alarms, and then for collision with the enemy bullet, it subtracts its health. Once the health is set to 0, it submits the game object for exit, and then resets the level. Collision with the health pack, collision with the ammo crate, scene exit, and scene entry. So let me go ahead and demo that everything works properly. So there is a collision with enemies and bullets. Player. So let me go ahead and defeat all the enemies on this level. There is ammo being used up. Assuming it's running really slow right now because of the recording tools going on right now. So right now I shouldn't get, that's not an ammo. There it is. Grab the ammo, so pick it up. Increases the amount of ammo we have. So now we have one enemy left. I'm assuming it is probably back here in the left corner. There it is. So it starts attacking the player. Pick up more ammo. There we go. So now we are in level 2. This is the second enemy attacking the player. It is a jet, fighter jet. And so that's to show that there is, oh boy. So I was having memory leaks because I had forgotten to clean up this ammo crate and this health pack. So I'm going to go ahead and show very quickly that that is okay now. So let me set up the start level now is level 2. This is now level 2, just to make sure that showing that there are enemy jets flying around. There they are. There we go. So no more leaks because I was missing those terminates. For the ammo pack and ammo crate and the health pack. Sorry about that. So that is showing that there is changing from level 1 to level 2, that there is a game life cycle, that there is collision between objects, and that next I want to show off that you can pause the game. So let's go ahead and move forward. It's paused. So now we are pressing F9 over and over and over, going through. And now we can recontinue. There we go. Getting shot at. Show that the player can take health. I'm pretty sure I haven't shown that yet. Now there's collision with enemy bullet. So let me go ahead and let the player die. Alright, and the player dies. There we go. So now we're back to the beginning of level 2. So, yeah, there we go. And to show that you can actually, whatever the starting level may be, so let me just switch this back to level 1. And then you can die in level 1 as well. And it'll reset to level 1. This might take a little while, but to demo that everything works properly, it's worth the wait. There we go. So now it's demoing that you're back at the level at which you were at. So right over here, we were at the beginning of level 1, so we're back to level 1. Memory leak passed. There are no memory leaks. Deleting the active cars. And yeah, I believe that covers everything for as far as the demo and all the code goes. Next, I will be showing off the documentation. So I'll be showing that off in 1 second.